Hi everyone. Can you see me? We should be live. Yeah. Okay. Awesome. Thank you everyone for joining the Gradio 4.0 launch event. We're very happy to see everyone here, um, and we will go ahead and get started. So my name is Abu Bakr Abid. I lead the Gradio team at Hugging Face. And today, what we're going to talk about is basically what we've been up to for the last few months. So the Gradio team, so myself, and you'll hear from a few of my colleagues as well. We've been looking at how really the community has been using Gradio and just building some very incredible applications. And we've kind of taken that and kind of tried to understand how people are using Gradio and use that to build in, kind of bake in some really, hopefully, I think you'll find very interesting, very nice features into Gradio. And we're very excited to share that with you today. So I'll be talking as well as a few of my colleagues. If you've used Gradio before, I think this will be interesting. Maybe you'll get to see some of the faces behind Gradio. Just out of curiosity, and maybe you can kind of share in the chat, are people here generally, would you say, are you new to Gradio, or have you kind of, are you pretty proficient with Gradio or somewhere in the middle? If you're joining from YouTube or LinkedIn, we're kind of mirroring to both the LinkedIn and YouTube. You can kind of comment in the comments, and then we'll be able to see that as organizers. Cool. Okay, so we have Duke saying uses it daily. Some folks who are proficient, some folks. It looks like there's quite a bit of a mix. So awesome. Okay, let's get started. So I want to start by actually setting the stage a little bit here. I truly believe that we're at a historic moment in the usage of machine learning. So my background is in academia. So I did my PhD in machine learning, quite a while ago. And I remember even just, up until a few years ago, building machine learning models was kind of niche. And when you trained machine learning models, you typically built them for other machine learning engineers and scientists to use. There really wasn't this idea that, I'm going to I'm going to train a model and I'm going to publish it so that anyone can use it out there. Then about maybe 5 or 6 years ago, Hugging Face came out with the Transformers library, and that's when it became like possible for software engineers who didn't necessarily know machine learning to start using machine learning models. In the last couple of years, something crazy has happened, which is that pretty much anyone who knows how to use a browser can access and use state-of-the-art machine learning models. And that's been made possible through demos, through GUIs that basically wrap machine learning models and allow people to use them in interesting ways. And in many ways, I think this parallels the development of personal computing devices, personal computers. Initially, it was just hackers, maybe very sophisticated engineers who knew how to use them. And now, personal computers, we're all using them. We're all joining through our phones or our laptops. And so kind of the same thing has happened with machine learning demos. Machine learning demos now go viral. Anyone can use them. And that's led to a lot of very interesting developments. There are some downsides. So for example, there's a lot of increased scrutiny. We've seen regulation around machine learning models, but it's also led to a lot of very cool developments. So why are these demos so important? Why are machine learning demos, why are machine learning GUIs so important? Well, first of all, as I've mentioned, they increase the accessibility of machine learning. It makes it possible for anyone, regardless of their background, regardless of their level of experience in machine learning, it lets them try out machine learning demos. It exposes hidden biases in machine learning models. So what do I mean by that? So oftentimes you have state-of-the-art machine learning models. They seem to do really well. You can kind of throw you'll see really nice blog posts. You'll see kind of very cool examples where the machine learning model is doing really well. But then you start giving it maybe a little bit unusual examples, maybe examples from different parts of the world where maybe it might not have been trained. So here's actually a state-of-the-art machine learning model that was trained with images of, it was trained to recognize images, really. It's an image classifier. And it was, when it's given a picture of a bride from the west on the left, it classifies it as bride or dress or woman, which are all reasonable predictions. When given a picture of a bride from Pakistan, where I'm from, it actually classifies it as performance or costume. which is incorrect and maybe even borderline offensive. So by making these models accessible and available to everyone, we help actually improve the underlying models themselves, or identify the kind of the biases or the weaknesses in the model. And then lastly, I think demos are really powerful because they refocus researchers onto what's actually useful to users rather than on benchmarks. So we many of us might have seen kind of quantitative benchmarks. Okay, how good is this accuracy or this other metric? But a lot of times, what's actually useful to real users is something that's a little bit harder to capture quantitatively. And I'll just give one example from a model that's from a demo that's trending right now in Hugging Face. This is a demo for a model called latent consistency model. And what it does is generate images that are very stylistically and kind of character-wise very consistent from one to another. Now, this isn't traditionally something that's you can easily capture in a metric, but it's something that's very important to users. Users who might want to use AI-generated images in comic books or kind of any sort of visual graphics. They want to be able to generate consistent graphics. And so by allowing users to try out your model through these GUIs, you can kind of help understand what users are actually interested in, and it helps align machine learning research with what users actually want. Cool. So I hope that makes sense. This is kind of why at Gradio we're very excited by machine learning models. At Hugging Face, we're very super interested in demos, or what we call spaces. It's one of like the three pillars of machine learning: data sets, models, and spaces or demos. But then this begs the question: how do you actually build demos? And if you're new to Gradio, or if you haven't used it before, I talk to a lot of people who want to actually build demos for their machine learning model. They've trained something pretty cool. They want to build a demo around it. They want to show it off with a web app or a mobile app. But then they quickly realize they have to learn Flask, Docker, just to kind of wrap their machine learning model in a way that can serve predictions. Then they need to learn JavaScript, CSS, front-end technologies. And then it's just like, maybe it's okay. I actually don't need to show off my machine learning model with a web app. And so this is why we built Gradio, really. We built Gradio because we wanted it to be possible for anyone to very, very easily, in just a few lines of Python, create a GUI for their machine learning model, and then serve it in a way that can scale up to thousands of users if you want. And so if you haven't used Gradio before, it's extremely simple to get started. So here what I have is basically the core class in Gradio. It's called the interface class. And the interface class basically takes in three things, which is a function, inputs, and outputs. So function here is your machine learning model's prediction function. So here it could be something that takes in some text and generates images based off of those texts. Inputs and outputs actually refer to one or more built-in Gradio components. So Gradio ships with 30 odd components. So things like text boxes, things like galleries, things like charts, things like data frames. And so all of those are kind of built into Gradio, so you don't have to worry about designing them. And so based off of these kind of inputs and outputs, a GUI is created for you. And then you go ahead and you do one more command, which was .q, and we'll actually talk about how you no longer even have to do this, but this creates a queuing system that can handle incoming requests. So now your GUI, your web app, can just handle many, many, many requests. And then when you launch it, if you add one more parameter, share equals true, it actually creates a public link where anyone can try out your machine learning model while it continues to run locally on your computer. So this is really powerful. You don't have to worry about web hosting. You don't have to worry about AWS. You don't have to worry about anything. You don't have to worry about getting a server, paying for a server. This is a free kind of way to share a link with anyone. It could be your colleague, your collaborator, your advisor, your parents. It could be anyone, really. And so, yeah, so that's kind of the maybe if I had to like boil it down, this kind of the most basic usage of Gradio. We released Gradio a few years ago, about 2019, and in the last few years, this really picked up. At this point, Gradio has about 50,000 unique monthly active developers, At this point, more than 15 million Gradio apps have been built and launched. So 15 million people who have built prototypes, or in some cases even very, very full complex web applications. This is the automatic 1111 repo. Many of you may have seen this before. It's a honestly something that is not something we thought would you could build something like this with Gradio, but there's an entire very, very complex GUI. There's a plugin system, an extension system. It's kind of crazy that people have built this with Gradio. And so, and then of course, there's also Hugging Face Spaces as well, which is the canonical way to actually deploy Gradio applications, again, for free. If you want to deploy it on a CPU machine, you can deploy it for free. And then you get all sorts of very, very cool, social features as well. People can discuss your demo. People can share output from your demo and things like that. Oh yeah, so I see here. Oh yeah, that's thank you, Ali Abdullah. That's correct. 500,000 monthly active developers. Okay, so that kind of leads us to where we're at today. So today is the launch event for Gradio 4.0, and I'll have the rest of the Gradio team kind of share more about what are the concrete features that we're releasing as part of Gradio 4.0. But I just wanted to lay out two broad principles. I think that will thread through all of the conversation for the rest of the presentation. And that is one thing that we've realized over the last couple of years is we can't anticipate all of the amazing use cases that the community, that you all are going to make with Gradio. We've seen, again, people, try things that, inject all sorts of JavaScript and custom CSS and do things like that. And so what we've decided to do is to try to expose more and more control to users, give more and more control to you all so that you can customize Gradio apps in a way that was not possible before 4.0. So we'll talk about how we expose the internals of Gradio in this structured manner. In particular, how you can build custom components. So I mentioned before, Gradio comes built in with these 30 odd components, but let's say you want to do something that's kind of beyond what those components allow. You'll be able to do that as part of 4.0. At the same time, we want Gradio to be a really robust foundation. So if you're building any sort of web app, you should have the confidence to know that these components are a good starting point. So we've integrated really good, kind of best practices when it comes to things like accessibility within Gradio's components. We'll talk about that as well. Okay, so with that, so the four things we'll talk about today are, first of all, custom components. Second of all, media components. We've redesigned them from scratch. We'll touch upon accessibility as well. We'll talk about server-side events, which I think will be interesting. And then finally, we'll talk about custom share servers. And there's lots of other stuff that's part of 4.0 as well. Unfortunately, we probably won't have time to talk about it. We probably won't have time to cover everything today. But if you have questions, we're happy to answer questions throughout the talk, but also, towards the end of the talk, we'll dedicate some time for questions. And then, of course, everything will be released. You'll have the changelog, and you'll be able to see everything that's part of 4.0. So with that, I'd like to bring up Pete, who is on the Gradio team, to the stage. Hey, Pete.
Hey, thanks very much.
All right. And I'm going to go ahead and share your screen. So feel free to take it from here.
Awesome. Thank you. So as Abubakar mentioned, I'm going to talk a little bit about custom components. So, it's become clear over the past probably over the past year or so that there's an increasing demand for, bespoke interfaces that users want to kind of present to their users so that they can interact with these models. And it might be that someone wants to build a complex application that needs some specific controls, or it might just be that they have a very specific model that needs a very specific visualization. And so custom components was born, and custom components allows you to build a custom input and custom output for your machine learning model. So it's pretty much limitless within a certain set of bounds, obviously. So as an example, this was probably the first request that we had that we thought would make sense as a custom component. And this is an image comparison slider. You've probably seen these things before. It's a really nice way. You can see you can drag and drop two images and then upload those to the Gradio server, and then you can compare those images again. And this is not a component that is available in core, but as you can see, it looks exactly like a Gradio custom component. It has all the same kind of UI elements and whatnot. But and this is really just a component that is it's a relatively small tweak of an existing component. It was based on our image component. And the only real difference is it's got a different UI and it takes two images instead of one. But you might want to build something more complex entirely. And so the always brilliant Simon Durr, who's been kind of helping us test custom components when we were in pre-release, built this amazing molecule viewer. So a 3D molecule viewer, and we have nothing like this in Gradio. We don't have the domain knowledge to do something like this justice or to maintain it, but Simon does. And as you can see, this is completely custom. You can load in these models. You can toggle a new screen, and all of this will be possible with custom components. And much more besides. So if you wanted to build, just normal UI elements for, extra controls to control parameters, if you wanted completely custom visualizations, inputs and outputs, then you can do that too. So we're incredibly excited about this because I think this 3D molecule viewer is kind of sums up the whole point of custom components, which is we may have some ideas, but when you put this in the hands of the open source community, when you put these in the hands of the users, that's when things really start to get interesting. So we just wanted to find a really simple way that we could allow people to create, develop, and even share their custom components. So you can publish your custom components to PyPy, and even if you're not interested in building custom components, using them should be as easy as installing a new package and just using them in your code. So what do you need to know to start building custom components? There are relatively few additional things you need to know. So Gradio core and custom components, there's not really a huge distinction between our components and custom components. They're built in very much the same way. They use Python for the backend and Svelte for the front end. It's the power couple we never knew we needed, but here we are. And a lot of people may be familiar with Python, especially if you come from a data science or machine learning background. But if you're not, it's obviously an incredibly popular language with a wide array of resources. And Svelte is a relative newcomer to the front end, but it's very similar to just writing plain HTML, JavaScript, and CSS. So it should have a relatively small learning curve for most people. A lot of the team are not front-end engineers, and I don't think anyone other than me has had prior experience with Svelte. And we've had pretty good feedback about how easy it is to get started. So hopefully it's not too much of a barrier, but we will be sharing more resources to allow people to get started, even if they have no experience even in either. In terms of Gradio itself, there's only 3 additional concepts that you need to, high-level concepts that you need to understand in order to start building custom components. So the first, and probably the most important, and it's something that people are possibly aware of anyway, is that Gradio components generally come in 2 variants. There's a static variant and an interactive variant. So I have the static variant on the left here, and it's just a simple output. It exists just for displaying data. This is typically what would kind of act as an output to your model, for your model. So it would just be for displaying images or for displaying text, and the user typically wouldn't be able to interact with it. An interactive component, however, that's where you allow your user to kind of to provide their own data so that we can perform a prediction on it, and then the result of that will be typically sent off somewhere else. So this is the image, the interactive image, where you can upload an image, you can drag and drop an image, you can capture from webcam, you can paste an image in, and we have a variety of components, and they not all of them, but a lot of them have an interactive input. Everything has a static variant, but not everything has an interactive variant. But these are the two kind of modes that a component can be in. So that's something to bear in mind when you're building it. This gives you the opportunity to build completely bespoke experiences. So you can think really carefully about, what do I want the experience for a user to be when they are kind of providing their own data, versus what do I want the experience to be for a user, when I'm kind of like displaying the results of a prediction. The second thing, and this is a touch more complex, but I'll try and keep it as understandable as possible, is processes. So we have these kind of pre-process and post-process methods that run as part of this this kind of pipeline when you kind of perform a prediction with Gradio. So if Vivekar showed the code before, and if you've used Gradio before, you'll know that, with interface, you typically have an input component, you have a predict function that's actually going to do the work, and then you have an output component. Processes run at either side of your user function. So we have a preprocessor that will run before the user function runs, and we have a post-processor that will run after the user function runs. This really gives you the data that comes into the preprocess, it's already kind of Python data types. So you've got kind of like real Python data structures to work with, but it allows you an opportunity to kind of provide your users with a better experience. So for example, when the image is sent from the front end, it's just a reference to a file. Now you could just pass that reference to the file to the user and let them load that file into memory and turn it into a real image that they can, do something with. But what the image component actually does is it allows the user to decide what type do they want that image in. So they can have that image as a file path, so they can indeed treat it as a file, but they can also get it as a NumPy array. They can also get it as a pillow image. And this is where the preprocessor comes in. So we will take this file data, we will load the file, and then we will instantiate a new pillow image or a new NumPy array. And that is what we pass then into the user function. And the same is kind of true essentially on the other side. We're returning, whatever we want the user to be able to return. You might want them to just return something like whatever they've kind of taken in. You might want to return that. So this allows us to convert, again, that kind of very specific data structure that, it's hard for Gradio to know about every possible kind of class that exists in all of Python. So this is an opportunity for you to kind of convert that into a plain Python data structure so that we can serialize it and send it back down to the front end where it will be received as, some kind of, JSON or something that we can easily transport and then render in the front end. So this is, while it is a slightly more complex concept, and it's typically not something that people have had to deal with before, it is an important part of custom components. You don't have to do anything in these instances necessarily. We certainly have some components that don't pre or post process in any meaningful way. But it does offer you an opportunity to provide like really, really nice APIs. So in the instance of the image, we have this type keyword argument, and you can pass, NumPy, pill, or file path, and that dictates the data structure that the user receives in their function. And likewise, these pre and post process methods, they aren't always a mirror of one another, but that is kind of frequently the case. So this is an important concept that will make a lot more sense when you actually start building and you have a need for this. But it is a core concept of custom components. And the final concept is examples. So if you've ever used a Gradio app or built one, you might know about this gr.examples or gr.dataset, which is what examples is under the hood. Or you may have just kind of clicked on these examples to populate the components on the screen. The way that these examples are created is that every component has an example component. And as with everything else, when you're building a custom component, you too can provide a custom example component. And the example component will receive the example that is being set. So in these cases, we've got, a mix, we've got a multi-select, obviously takes a list of options. An image takes an image, a video. And you can decide how you would like to render that example. And typically it's a a kind of like a slightly reduced version of the core components, but you can do whatever you want. And it's worth mentioning that these examples, they will also receive all of the keyword arguments that the component takes as well. So if your component renders very, very differently depending on what kind of options are passed, you have access to those options in examples too. And this allows us to render your component alongside, one of these could be your custom component, and you wouldn't know it was a custom component. It fits perfectly into the UI. And so these examples are optional. We do have a fallback where we'll just render the value. But if you have a particularly engaging or bespoke custom component, you might want to provide a custom example too. So what is it like to build a custom component? So I'm going to hand over to Freddie now, and he's going to talk us through the process of actually creating a custom component.
Hello, everyone. Let me close this for now. I'm Freddie. Nice to show you guys, or nice to meet you all, and I'm excited to show you how you can get started building custom components directly with Gradio 4.0. So the main way that you create custom components is via a command line interface that we just launched. That's called Gradio component or Gradio CC. So if you have the latest Gradio installed, you do Gradio CC help, and then you get a list of all the commands that you can do with custom components. The first step of creating a custom component is to create the scaffolding of your project, right? So you do that with the create command. And before I get started, maybe I should say like what it is that I'm going to show you. I'm going to show you guys a custom component to display map data with Gradio. So we've gotten some requests in the past about improving Gradio support for geospatial data. I'm going to show you how you can just unblock yourself, not wait on us, and just build your own custom component to do that. So the way that we're going to do that is we're going to use a Python library called Folium. That it's like a Pythonic API for creating maps. Okay. So with that said, the first thing we're going to do is we're going to create our component. So I'm going to call it Gradio CC create my Folium, and then you'll get started. So what this is doing, it's creating a directory for you. It's creating some scaffolding backend code, front-end code. It's installing any Python dependencies, so Gradio in this case, and it's also installing the JavaScript files that come with the component. So that's how you get started. So rather than me typing all of these, rather than you seeing me type, I'm gonna show you guys what the finished code looks like, and then just to show you all the features. So this is what the directory looks like. So there is a backend folder, a demo folder with the demo to show off and test your component, a front end folder, and then a PyProject TOML file and the README. So in the TOML file, here you pick the name of your package, the version number. You configure your project via this file, and then importantly, you list the dependencies that you need here. So in this case, I manually edited this file to add the Folium dependency. The Gradio dependency was already set by the CLI. And then, I'm just going to kind of go through the backend and front end changes and then show you guys the demo at the end. So in the backend, everything is implemented in this Python file. So by default, it's the name of the component, that you chose. So in my case, I chose Folium test. And then, this is, if you're familiar with Python, this is like a normal Python class, with the only Gradio specific exception being that we're subclassing the component class. So this is how you declare a custom component in Gradio. And then we're just going to go top to bottom here. So this is how you define the events for your component. So you just specify a list with all the different events that it can take. In this case, I'm just going to support and implement the change event. But you can pretty much put anything in here as long as it can be a valid Python method name. And then whatever you add here will be a method available on your component that you can use to trigger an event. And then the other big thing, or the other new thing, if you're familiar with how Gradio 3.0 works, that's new in Gradio 4.0, is this idea of the data model. So the data model is how you specify the data that your component will receive and send back to the server. So it's very intricately tied to the pre-process and post-process concept that Pete talked about earlier. Yeah, basically the server will send you your data model, and then you're expected to return your data model from post-process. And then, this is, I'm just going to create my class. I'm only going to add 2 keyword arguments, just height and label, and then just set the height of my class. And then the pre-process, we're not really doing anything here because I'm envisioning this component being used mainly as output. So we don't really have to do anything for the pre-process. And then for the post-process, what we're going to do is just take a Folium map. So this is what the user will return from their Python function. They're going to return an instance of the map class from Folium. And then what Gradio is going to do under the hood is just turn that into an HTML file that the front end can serve. So that's what I'm doing here. I'm just creating an HTML file, saving it to that directory, and then I'm returning the file data, which is my data model, which is telling the server where to get this file from and what the original name of it is. Cool. So now let's go to the front end. So the main entry point for all your front end files will be an index.svelte. And here's the example.svelte that Pete was talking about earlier. So over here is just some standard Gradio imports that come built in with your component. And then the only thing I modified was to, type the value as a file data. And then all I did here was just that if the value is set, I just embed an iframe pointing to the URL of the value. And then if it's not set, we just have like an empty box to let the user know that the value has not been set yet. So I think I went a little bit fast, but at the end of the day, what you need to do is just go to your Python file, define your events in your data model, and then you implement pre and post process. And then you just make whatever front end modifications you need to display your component. So in this case, since we're just displaying an HTML file, we could just use an iframe. Okay, so once you have built and created your component, the next exciting thing you can do is kind of test it out locally before you publish it. So to do that, the CLI comes with a dev command. So you do Gradio cc dev from within the directory of your custom component. And then this will launch the app.py file in the demo directory in a front-end server. So you go to this URL here that says front-end server. Where did it go? Oh, here we go. Sorry. So here's my demo. So I'm going to show you guys what the demo code looks like. So what we're doing is just that we're picking a city in the world, and then when we click on the radio button, you'll get a map of a map centered on that city. So that's just kind of what we're doing here. Just standard Gradio block syntax, and then we set up our select event on the radio, and then here's the map that we're returning. So let's see how that works. So yes. Okay, I think there's a bug where the name isn't matching, but you get the idea that the city changes with the map. But okay. And then another cool thing I want to show you guys is that this server reloads all your Python and front-end codes automatically. So you don't have to restart the server every time you need to make a change. So for example, if I just want to change the label to map, you can see that the label changed automatically. I think there was a little bug there. Cool. And then the other thing I want to show you is with the index. The same thing happens with the index, the svelte file. So if we change the icon of the empty box to be a file instead of a plot, you see that it has a file icon now, but now it changes to a plot. Yeah, so you can iterate really quickly on your custom component by modifying the backend and front end files. Cool. So I'm pretty happy with what this component is doing right now. Save that bug that I'll fix later. Right, so once you have implemented both the front end and back end of your component, what you can do is build it. So you do Gradio CC build. And then what this will do is it'll package all of your front end assets and your Python code and build a wheel file or a Python package that anyone can install. So we'll see, we'll give it a little bit of time to do that. So here, this is what it created. It created this wheel file as well as the source distribution. So you could install this right now in Hugging Face Spaces, or you could send this file to anyone and they can install it locally and they'll be able to use your component in any Gradio demo. But it would be cooler if they didn't need this file at all. They could just download it, if they could download this file themselves from the internet. So Gradio makes that really easy for you with the publish command. So the publish command walks you through the process of sharing your component. So there's two parts. You can upload to PyPy and upload to Hugging Face Spaces. So we're going to do both. So we're going to upload to PyPy. What you need is a PyPy account, and here it tells you where to go to create one. So I'm going to just give it my credentials. And then here you go. It's uploading to PyPy. That's the link. And then it also asks you to upload a demo to Hugging Face Spaces if you'd like. And by default, it'll upload the demo that you created locally. So yeah, by default, it's the demo directory. And then it also asks you if you'd like to share your source code so other people can look at the implementation and fork it from Hugging Face and make modifications. So we're gonna do that as well. And then it's going to upload to Hugging Face Spaces. So then if I go here, I see the demo. So it's already running on Hugging Face. And then here we see the source code. And then if I go back here, it creates a PyPy project for you. So now anyone can install this in their machine. On Colab, they can put this in the requirements.txt file in Hugging Face, and they'll be able to use this component in their demo, as long as they have Gradio 4.0. So stop sharing now. So that's all I had to show you guys. Thank you guys so much, and yeah, really excited to see the custom components that you build.
Thanks, Freddie. We've also put together a written guide for how to create custom components. So that's published on the Gradio website, and then we'll be sharing that afterwards as well. So we're going to go ahead and change gears now. So we've talked about custom components, and we talked about custom components at length. Just for the sake of time, the other items that we're going to talk about are going to be much faster. But I'm going to hand it over to Hannah, who will be talking about the media components.
Thank you. Hi, everyone. Nice to meet you all. I'm Hannah, one of the front-end developers on the team. And yeah, I wanted to talk to you today about the media components that we're releasing, which we've refreshed a little bit. So firstly, we have the, could you go to the next slide? So we have the video component. So before it was a nice looking video component, but we've now added some functionality to trim the videos. So yeah, you can see from the from screenshots, you can just trim a selection of the video, so people can upload a certain amount to run through the prediction, certain part of the video to run through the prediction function. You can trim it, and then you can also revert it to the original state. Another part of this as well is that we've added source selection. So before we were only able to select whether it was an upload or webcam input, but now people can switch between the two, which is great. And yeah, here's a little demo of how that looks if that's running.
I'm not sure if it'll play that through StreamYard, but
maybe not. Well, on to the next one. So this is the image component that's also had a bit of a refresh, which is great. So this too has had changes to the source selection. So you can now upload and select capturing via webcam and also copy and paste into the component. And lastly, the audio component. So before, again, we had this audio sort of view, and you could also trim it, obviously, as some people know. But now we've actually added sort of a waveform view corresponding to the audio. So when people record, they can see the live waveform, and also when they output, they can see the waveform of that audio. On top of this, as well as the video, you can also trim it, you can edit it, and of course you can change the playback speed of the audio, and again, source selection as well. So you can change whether you upload the file or also capture via microphone. So that's awesome. Another thing as well is min and max length params have been added to both audio and video. So now you can specify whether how short or long the audio or video can be sent through the predict function. And this is an example of the Koki XCCS space, which is currently trending. This is what it looked like before. Still works, is very cool. And now this is it with the new audio component. And yeah, as I said, this is trending, so you can give this a go and yeah, have a play around with this space, which is really cool. So yeah, so we fixed up a few bug fixes with these components, improved the accessibility and the UX. As I mentioned as well, trimming, min and max length, copying image from clipboard into GR image and multiple sources. So yeah, very excited about that. And just so to touch on accessibility as well, so this is the Koki space, and it's also navigable by the keyboard. So you can trim, you can use the handles on either side. You don't have to use a mouse for anything. So all very accessible, which is great. So yeah, so to expand on accessibility, with the growth of our monthly active users, we've been very mindful of making this much more of a priority to make sure our spaces are accessible to everyone. As anyone knows who's worked on accessibility, it's always a never-ending feat trying to improve it, but I feel like we've made loads of progress in the past few months on it, which I'm really, really proud about. And yeah, so we've had an audit of all of our components, made sure they're keyboard accessible. We've made sure that we've improved the HTML semantics so that the apps are meaningful for all screen readers. Icons as well, everything is labeled as necessary. We've been very mindful of the colors that we've been using, making sure that it's very readable with people with certain needs on screens. And we're going to be carrying out a lot more accessibility audits going ahead. So yeah, very excited about that. Really proud of what we're doing. Plenty of more updates coming in the future because, as I said, there's always room for improvement. But yeah, very, very happy with where we are now. So yeah, that's all from me. Thank you, everyone.
Thank you so much, Hannah. That's awesome. Okay, so we are going to change gears yet again, and we're going to talk about one more change in Gradio 4.0. This is a pretty big change, and here we have Ali talking about it.
All right, hey guys. Yeah, we're gonna shift gears a little bit. I'm gonna talk a little bit about how we changed some of the protocols that we use for communication between the Gradio front end and the back end. And so previously we used two types of requests to communicate between the server and the client and the server. We used HTTP post requests for quick like updates. We'd send the data payload, we got a response back. But those had some limitations. So the problem with HTTP post requests, there are basically two problems that we ran into. Was that, well, the first one was that any type of HTTP request like that times out in 60 seconds. So if you had any complex app or you had like a bunch of requests piling up and it took 2 minutes to get a response from your app, which is not uncommon in a heavy machine learning app, the request would just time out. The other problem was that you couldn't send any messages along with the output during the processing of the function. So a lot of the features within Gradio, so for example, sending updates on how long the queue is going to take, or if your function is an iterator, getting the yielded outputs things like that require sending data along with while the function is running. And a post request only sends one piece of data to the server, and the server sends one piece of data back. And so we needed to, in Gradio 3.x, we added support for WebSockets because WebSockets support bidirectional flow. So we could be sending messages back and forth from the client to the server. And that's how we were able to support features like updates in your queue, like iterative outputs, like pop-up info warning modals that can come up while the function is running. But WebSockets came with a bit of baggage of their own. They are a little unwieldy. They're not easy to set up behind a server. They're not easy to do load balancing with. And so we moved over to a new protocol, and we've unified what previously we had HTTP post requests used sometimes and WebSockets used sometimes. Now we've unified everything to use server-side events. So server-side events are similar to WebSockets in that there is multiple messages being sent. But the difference is that there's only one message sent from the client to the server, and then the server is sending messages throughout, can send multiple messages back to the client. So if you see the WebSocket example, there are requests going back and forth, whereas the server-side event, we're only getting updates from the server. There's a unidirectional after the first response is sent. So why do we care about that? Why should you care? The reason is the server-side events are just much better supported across pretty much everything because they are simply just a text HTTP protocol. So this means better device support. We more mobile support, better handling if the connection drops off, better scaling if you are serving your Gradio app behind an Apache server on AWS using load balance. It also makes it much easier to integrate with other technologies because WebSockets are kind of unwieldy, whereas you can use just a straight up curl command to integrate into your Gradio app. So in this example here, I just curl my local host where the queue is running, and I'm getting responses back. So you're basically running Gradio literally in your terminal, which will allow you to integrate or use Gradio as a backend much more easily. Obviously, we do have a whole Gradio client separate library that makes it that provides more helpers to use Gradio as an API. But just using a simpler, better supported technology, I think will encourage people to use Gradio as a backend much more comfortably. So along with this, while we were unifying how we handle our requests, not only did we unify what protocol we're using, but we also unified the queuing mechanism. So previously we had the option where you could have your requests be queued up or they could not be queued up. And these were two separate ways. And there were some features that were supported with the queuing system and some that were not. We kind of unified everything. Now everything uses one queue and you have much more better control of this queue of requests that are being handled. So in Gradio 3.0 previously, we had, if you enabled a queue, you had one queue, you had a specific set of workers, and as the requests came in, they would get piled into the queue, and workers would take them off one by one. And you had some control over the flow of this queue. You could set the number of workers. So if you knew that, your app couldn't handle, serving 20 requests because some of your event listeners have heavy machine learning processing, you could control how many workers are being sent. But you didn't have very fine-grained control. So it could happen that if you had like one heavy machine learning request that's taking 20 seconds to parse, and then another user submits a very quick request of a different event listener that just needs to maybe update the UI or do something simple, it would get stuck behind the other queue request, and then that one would take 20 seconds because it's waiting in queue. And so we wanted to make it so that you have much finer-grained control over your queue. And so we moved away from this single shared queue system where there's still one queue, but now you can specify how many workers are dedicated for each task. So let's say, for example, your web app has one machine learning model inference, which requires GPU, and then has another function that maybe saves some files on disk that takes maybe a couple seconds, and then it has another function that just updates the UI. You may want it so that your machine learning model only has a maximum of 2 threads working at most at once, because any more than that, then you're constrained by GPU and you run into errors. You might want the file system one to maybe have more workers, maybe at maximum 10 can be working in parallel. And then your last one, the one that's just a UI update, you could have like 20 workers at most working in parallel. Now you can set this per event listener. This way, events of different types aren't blocking each other necessarily. So if there's one very heavy type of event, it's not blocking the queue for the other events. You have fine-grained control of how many workers are set per event. And we think that this will allow like much finer-grained control of how your flow works and how your queue is set up. So we've unified not only the protocol, but also the fact that all the requests are being served through this queue, and you have much more finer control over that. Yeah, that's pretty much everything for me. Thanks for listening, guys.
All right, thanks so much, Ali. And let's change gears yet again, and now we'll talk about the final new kind of feature in Gradio 4.0. Of course, there's a bunch of other things that we won't have time to cover, but the last thing that we wanted to cover in this presentation, which is custom share servers. Okay, so if anyone has created a Gradio app before, and I mentioned this at the beginning of the talk as well, you know that you can easily create a public link for your Gradio demo, right? All you do is you do .launch, share equals true, and you get a public link that looks something like this, some different hexadecimal kind of digits, and then .gradio.live. Now, this is fine, but how does this actually work? So what's actually happening under the hood when these public links are created is that Gradio continues running on your local computer. And so your Gradio application runs locally on a server that's been created. And then Gradio uses something known as fast reverse proxy. And what that does is it exposes your local port. So your local port gets exposed on a public machine, on a public server. And that public server has a public IP address, which kind of forwards requests, to your machine. And then your machine takes those predictions, sends it back to the Gradio share server, and then which then sends that back to the users on the internet. And so from the perspective of a user, they're just using a web page. But what's actually happening is that the Gradio share server is kind of message passing, back and forth in order to make this work. Now, the big new thing in Gradio 4.0 is that this share server that's in the middle here, it doesn't have to be Gradio's share server anymore. It can be any share server. Meaning that let's say you have a startup or you have a company that you work for. Let's call it mygptwrapper.com. Now, what you can do is you can set up a share server on your own domain. And once that happens, once you set up a share server on your own domain, you can actually point Gradio to it, and Gradio will create a link that's kind of like a share link on that domain. And so practically speaking, what we've done is we've open sourced the actual last piece of Gradio that wasn't already open sourced, which is this share server that's based on FRP. So we've open sourced this. You can see exactly the code that we have for our share server. And that exactly. So Dale mentioned that, the 72 hours limit is irksome. When you set it up on your own devices, on your own machines, on your own servers, you don't have to have any sort of timeout, or you can increase the timeout. You have full control over the code. And we've actually, laid out instructions describing how to change the timeout or how to do whatever you want in order to, set up this share server so that you or your colleagues can do it. And then in terms of being able to use it within your Gradio application, we've added another parameter to launch, and that's called share server address. And what that parameter takes in is the domain and the port, the FRP port. And so again, all of these instructions are available, but basically once you do this, you get a very nice kind of, share link that runs on your kind of own devices for as long as you want. Now, of course, That is one way to do it. The other way, which is already available and it's going to be continue to be available, is for you to be able to share your Gradio demos on Hugging Face Spaces. And of course, we do recommend this because then you get kind of a lot of nice features like discussions and so on. And who knows, you might be able to get custom domains as well. Just stay tuned if you're interested in that. Sweet. With that, we're going to start actually closing things up. So there's a lot of other stuff that we didn't get a chance to talk about. Proper support for JavaScript functions, much better file security. So if you're worried about users being able to access files on your computer, we've revamped this. You can have a lot more control over the meta tags in your Gradio application. Any sort of JavaScript you want to inject, such as Google Analytics, things like that. You can now do that in Gradio 4.0. You can even control exactly which events get processed when and concurrently using a new parameter we added called trigger mode. These are things that if people have questions, we're happy to talk about. But just for the sake of time, I think we'll pause there. Yes, thank you so much, everyone, for joining us today. And we'll take a little bit of time, maybe 10 minutes or so, to answer any questions during this live stream. And then, of course, we're happy to answer questions after the live stream on Twitter and on Discord. Those are the two places where the team hangs out. So feel free to find us afterwards. And we're happy to help you upgrade to the latest version of Gradio. Are there any questions that you all have for the Gradio team while you have us here? We really want custom domains. Awesome, perfect. Yeah, so it's supported in Gradio and it'll be supported in Spaces probably soon. So stay tuned for that. So we have a question about release notes. Release notes, I think, should be available. Maybe Ali can maybe Ali can chime in on that. Ali Abdullah, if you want to respond in the chat, that'd be great as well. So a good question from Maulik. Do we have backwards compatibility as we have many demos? That's a great question. So Gradio 4.0 being a major version, there are some breaking changes. There aren't too many, and depending on the complexity of your Gradio app, it might be possible that you can just upgrade and your code works as is. The UI will look a bit different, and that's intentional, of course. But if your app uses certain things, you might have to actually change the code a little bit. There might be some breaking changes. Part of the release notes is kind of like a migration guide, so a list of all of the breaking changes and what you need to do in order to start using Gradio 4.0. Cool. There was a couple other questions. Is this presentation online anywhere? I believe it will be. It will be. I think it'll be available on YouTube after this live stream is finished. Question from Jackie Lee: How can I disable waveform display and audio component? Currently not possible. We've designed it in a way that hopefully won't be too obtrusive. But if that is important to you, please open an issue and we can consider it. But also now you have the power to do custom components. So you can create your own custom audio component that it's kind of doesn't have this nice waveform if you so want. Does Gradio Lite work with Gradio V4? Yeah, so good question. So Gradio Lite is pinned to a specific version of Gradio. So every release of Gradio Lite is pinned to a specific version of Gradio. So the current version of Gradio Lite that is released is pinned to Gradio 3.x. So that's actually a good question, a caveat that you should know of. But we'll soon upgrade it. We'll release a new version of Gradio Lite that is fully compatible with Gradio 4.0. Question about projects related to Gradio. This is a good question. Maybe if anyone from the community wants to suggest projects for this LinkedIn person, feel free to suggest projects there. So Dale, so I can't use it right now. So you should be able to pip install Gradio 4.0. You should be able to try it. If it doesn't work, let us know, or feel free to create an issue, but it should work. Sweet. Are there any other questions? All right. Well, once again, on behalf of the whole team, thank you so much for joining us today. And feel free to find us on social media if you have any questions, and we're happy to help. So good luck building.